All right, chapter 8.1, exploring exponential models. All right, in this lesson, we're going to learn how to model exponential growth and exponential decay. So things we're going to learn are exponential functions, growth factors, decay factors, and asymptotes. Okay, let's just go start. All right, for some data, the best model is a function that uses independent variables as an exponent. So an exponential function is a function with the general form of y equals abx to the x power, where x is a real number and a is not 0 and b is greater than 0 and b is not 1. You can use an exponential growth function to model growth when b is greater than 1. When b is greater than 1, it is a growth factor. So it is again written as y equals ab to the x power. So how do we graph an exponential growth function? All right, we go back to plug and chug. Pick a few negative numbers and a few positive numbers for x and then solve for y. So you can see they made a table, okay, and they plugged in x is -3. They found out what 2x is and then found out what y is. Okay, and they did it for -2, -1, 0, 1, 2, and 3. So you can see we plotted our points for -3, -2, -1, 0, 1, 2, and 3, all on the x-axis, and we plotted whatever the y value is. So we're going to connect the points and create a smooth curve. So this makes sense. Exponential growth. As x gets bigger, y exponentially grows. Exponential growth. Okay, so let's just graph y equals 4 times 2 to the x power. So let's just make our graph again, or our chart for x and y values. All right, we'll go -2, -1, 0, 1, and 2. So when x equals -2, y equals 4 times 2 to the -2, which is 4 times basically 1/4, which is 1. Okay, so when x equals -1, it's going to be 4 times 2 times -1, which is basically 4 times 1/2, which would be 2. So when x is 0, okay, anything to the 0 power is 1. So it'd just be 4 times 1, which would be 4. So when x equals 1, it'd just be 4 times 2, which would be 8. And when x equals 2, it'd be 4 times 2 squared, which would be 4 times 4, which would be 16. Okay, so when x is -2, y was 1. When x was -1, y was 2. When x was when x was 0, y was 4. Okay, when x was 1, y was 8. 4, 5, 6, 7, 8. And when x was 2, y equaled 16. So there we have our exponential growth. So we know it's going to be close to 0, and it's going to work its way up. There you go. Exponential growth. It's going up and to the right. Okay. Easy enough to plot. Okay, let's move on. So you can use exponential functions to model population growth. If you know the rate of increase r, you can find the growth factor by using the equation b equals 1 plus r. Okay, b equals 1 plus r. Don't forget that. So let's look at our growth. Okay, refer to the graph. In 2000, the annual rate of increase of the population was about 1.24%. Find the growth factor for the United States. Suppose the rate of increase continues to be 1.24%. Write a function to model the growth. All right, step 1, find the growth factor. That's just b equals 1 plus r. Well, we knew the rate was 1.24%, so we convert that to decimal point, or make it 0.0124. So our r value is 0.0124. So our b value is 1.0124. That is our growth factor. So now we got to write a function. Well, y equals ab to the x power, ab to the x power,
So the population increases exponentially. So we're going to use y equals a times b to the x power. Okay, we'll let x equal 2,000, the number of years after 2,000, and y equal the population in millions. Okay, so y equals a times 1.0124 to the x power. So 281 equals a times 1.024 to the 0 power. So we're going to find 281 equals a times 1. So where did we get 281 and where did we get x from? All right. Well, in 2000, the population was 281 million. So x is our years. So we made x equal to 0 and we made the outcome equal to 281. So our function is nothing more than y equals 281 times 1.0124 to the x power. Okay, remember that. Okay. So the next question, so y equals 281 times 1.0124 to the x power. So predict the population in 2015 to the nearest million. So y equals 281 times 1.0124 to the 15th power. Okay, that's a job for our handy dandy calculator. Okay, so we can plug that in. Get this where we can see it on our screen. So we can just type that in. 281 times, in parentheses, 1.0124 to the 15th power. So 338 million. So about 338 million, which makes sense. Population is going to go up. All right. So write an exponential function. Well, you can write an exponential function y equals abx for a graph that includes 2 points. So if we have 2 points on the graph, we can graph the exponential function. So here's what we do. We pick the first point, 2, 2. Use the general form, y equals ab to the x power. We plug in the coordinates of x and y using 2 and 2, and then we solve for a. Okay, so we're going to solve for a in terms of b. Okay, now we go back to the general term. We're going to replace x and y with the x and y of the second point, and then we're going to use the a value in terms of b that we had. So, and then we're just going to simplify and solve. Okay, so you can follow along through here, see how it did it. Not too difficult. So let's go to the next example and do it ourselves. So write a function for y equals abx for the graph that includes 2, 4. So our first point, our point 1, and I like to do this, x and y, was 2 and 4. Our second point was 3 and 16. So step 1, we're going to use our first point. I'm going to use blue. So for, well, let's start with basics. Y equals ab to the x power. So it's going to be 4 equals ab squared. So solve for a. So divide each side by b squared. So a is going to be 4 over b squared. That's important for us to know. Second step, go back to the original equation, y equals ab to the x. Use our second point for x and y. 16 equals, but instead of using a, we're going to use our new function, 4 over b squared times b cubed. Okay, so I got 16 equals, well, 4b cubed over b squared is going to simplify to 4b. Okay, you guys remember how that happens? b cubed over b squared is nothing more than b. Okay, don't forget that. Divide each side by 4. 4 equals b. Okay. So now we can go back to either equation and just plug in, or let's actually go back to our a equation and plug in our b equals 4. So we're going to go a equals 4 over b squared, 4 squared, which is 4 over 16, which would be 1 over 4. So my a variable is 1 over 4. My b value is 4. So if I got y equals ab to the x, my y would equal 1/4 times 4 to the x. Okay, look that over. Make sure you can follow the steps. And we'll continue in just a second.